How y'all doing? My Saturday stream. And what I'll be doing is talking a bit about the presentation that you can see now that I gave this week. I made a 95 on it for the presentation part. So I made just a few slight updates on it by the time the presentation came, but it's pretty much what it was. And you can let me know if you have any questions about it. And were you here to see the original discussion of this presentation, Splurge? Okay, well, we better get the full one right now, a bit updated then. So we'll go ahead and do that. So I'll start with that, and which won't take long. It was designed to be like a 10 to 13 minute presentation, and then we had a question and answer. So I'll go ahead and do that, and then I'll talk about a favorite part of a debate. MCToon had a debate recently, and I thought one part was so funny. I've seen it so many times already, so I'm gonna show that a little bit. And and I noticed there's another debate going on now with what I believe to be one of the most despicable flat earthers. Which is why I wasn't even going to watch it at all. But out of curiosity, I had to plan a little bit, and I noticed Mark Reid is coming on strong at the start already. So I may flip to that and talk about that a bit. And at the end of my stream, I might go finish watching that a little bit while I do homework. So we'll see. So presentation. As you can see, it's on the stellar mass and rotation as a function of position within the Praesepe open cluster. Now, this research is not finished yet. So if you remember, I had mentioned that I'm going to present this research next year. So it's not that I'm presenting the research early. It's just that this is the early stages of it. So basically, for my research class, it's it's introductory research class. So you don't really have to, you know, we just had the report was limited to like 2 pages or 1,500 words. It was meant to be a very small, brief thing, a sort of an introductory investigation. So my introductory investigation, which is what I have here, I presented to that class. But my actual research, like the full breadth of it, that I'm going to present at a conference in March of next year, that I'm going to be doing over the winter. So I might talk a little bit. Actually, I have in a presentation a little bit of what I'm going to do to update it and improve it. But you could say that this is the preliminary stages of the investigation. That was enough for an introductory astronomy class, but the actual full research won't be finished until next year. So you'll see me come back again and mention that. Maybe I might even try to report my actual talk I give at there's a conference in somewhere. I don't even remember where it's at. I just know it's in March. And it's a big conference for the people in my research organization that I'm in. That go there and present what they did. So, but no more news on that soon. What's going on, Brandon? How you doing? So basically, as the title suggests, I was basically looking at the distribution of mass and rotation in star clusters and trying to see how they distribute it. Try to see if I could denote some kind of pattern. My hypothesis was that it was distributed radially, that I would see some kind of radial distribution. You'll see I didn't find that. So this is what the Praesepe cluster looks like. This is an actual picture by Lauterbach. And as you can see, the stars are pretty randomly placed. It's not like the Pleiades constellation, which is also an open cluster. But there's 7 prominent stars in Pleiades. It's very visible in the sky. This constellation would just look like a blob of stars, but it has been known about for centuries, since the early BC. It's been plotted. It has a little over 1,000 stars in it. Is located in the Cancer constellation, and it's a few mega years old, but it's still relatively young as far as stars go, which makes it easy to investigate, because younger stars or main sequence stars, they're on the main sequence stars. There's a consistent relationship between luminosity and temperature and things like that, so it makes it more easy to investigate. Uh, Now, the basis of my investigation is the fact that stars have spots on them. We call sunspots or soft spots, or sunspots or star spots. So if you look at the image on the left, That's a picture that I took of the sun myself, August of this year. And as you can see the little dark spots on the sun. That's not an error of the camera or anything. That's actually what the sun looks like. And on the right, what I did was I went into the archives of these satellite photos because there's satellites that are orbiting the sun that all they do is focus on the sun and take pictures of the sun in various wavelengths. And this particular wavelength, you can actually see the magnetic field lines. So what you're seeing on the right are the field lines of magnetism in the sun. And if you compare these images, they're from the same time, literally almost the same minute. So we can take a look and see what the magnetic fields of the sun look like compared to these spots. And as you can see, the magnetic activity here corresponds to these two spots here. And same thing, you have some high magnetic activity here, and it corresponds there. Let me see if it'll help to use the marker thing. There we go. So you can see that these correspond. Same thing here. You see there's a high amount of magnetic activity here, and we can see that there's some sunspot activity here. So what's going on there is when these magnetic fields are arcing into the sun, at that location, they cause the sun to be cooler. In that cooler area is less illumination, because we know if we heat like a piece of metal, the hotter it gets, it starts to glow. First, it starts to glow red, and it glows brighter and brighter. So the same thing with the sun. When the temperature goes down, the luminosity goes down, and thus we have star spots. That's another reason why sunspots occur in pairs, because there's one spot where the uh, magnetic field arcs out, and another spot where it arcs back in. And you can see that on some of these spots. You can see there's a loop, and at both of those places where that loop touches the sun, you'll see two connected sunspots or star spots. And by the way, if anybody have any questions, be sure to let me know. Now, if you look at this, what happens is since the sun is rotating, these spots, of course, take a certain amount of time to traverse the sun according to the speed that the sun is rotating. So if you look at this image up here on the right, this is actually what's called a light curve of a star in Praesepe. So what we can do is we can point our instruments there. This was done with the Kepler telescope. We can measure the luminosity of it, and we can see that this luminosity has a period. It goes up and down. And then what they did was they used an algorithm to calculate the period of this oscillation. And then we get that this star is spinning at 1.59 days. So every 1.59 days, we can see that a spot moves across the sun. And that's what this is. Because if you look at the sun, if there was no spots, it would be a little bit brighter than the spots that's there, causing it to be dimmer. And as these spots move across the sun, it's a very periodic. Uh, it's a bit dimmer when this is in the center. When this is on the side, it'll be a bit brighter, and so forth. So that's how we get the period of the rotation of stars. And this has been a very tried and true method. Another thing they did, by the way, they actually used several uh, campaigns, they called it, of Kepler to take the same star measurements. And my mentor suggested that I recreate some plots from the actual official document of the researchers, Grant Polly and her team, to confirm that I had the right data and I can do it properly. So if you look at this, the left graph is of the C5, campaign 5, and C16 of Kepler, the rotation of these stars. The middle one relates campaign 5 and 18 and campaign 16 and 18. And we can see how all three of them have a very strong correlation. There is some extraneous data up in here that I had to take out, but in this plot is an early plot. I was just making sure that I had the right data and I could look it up. So that was an early plot I made. So this is actually a distribution of what Praesepe looks like. If I actually just plot all the stars, this up here has all the stars plotted, and this one is zoomed in. If you look at this, what I did was the size of the plots, the marker, relates to the size of the star. So the stars go from 0 to 1.6 solar masses. I had to multiply that by a few hundred, because even if I just set the plot to be the actual sizes, 1 versus 1.6, and marker size is almost nothing, so they all just look like dots. So these stars they're not really that close in real life. They're more like pinpricks with a large distance between them, but I increased the size of the stars several hundred-fold to make that easier to see. This is what it looks like in some of my early plots. And here we can see how the period of rotation of the stars in Praesepe correlate to the mass of the star. So it's interesting that the high mass stars have a low period of rotation, which means it takes very few days for the star to take a full spin. So that means it's spinning faster. So the more massive stars and the least massive stars spin the fastest, and these stars around 0.3, 0.4 solar masses take the longest time to spin. One of them even going up to 40 days to spin. So that's a very slow spin. So I found that to be interesting. That's not the focus of my research. And this is just a histogram. I figured it'd be interesting to see what the distribution is like. So at the bottom of this plot here is the period, the period of rotation. On the left side is the number of stars that rotate at that pace. So we can see the majority of stars rotate very quickly. So the majority of the stars would be necessarily large stars or small stars, mostly small, most likely, because a lot more small stars than big ones. So it makes sense that since the small stars rotate so much quickly, that the majority of the rotation to be angled around the small stars as far as the lower period of rotation. And down here we can see the number of stars at certain masses. So we can see that the majority of the stars are very small. Over 200 stars are about 0.3 solar masses. About 40, 30, 40 is at 1 solar mass, a mass of our sun. And very few stars are, almost twice as big as the sun, which is consistent with the IMF. So we have a understanding of the distribution that stars take when they form. And we know that for every very, very large stars, more smaller stars form. There's actually a formula for that. It's called the IMF. I forget what the actual letters stand for now because I'm used to saying IMF. But basically, it's a way of we can calculate and estimate how many stars or which sizes are formed over an entire mass of stars. So the Praesepe cluster, it has about 511 solar masses altogether. At least that's what of the stars that I know of from the data I got. That's what I added up to, about 511 solar masses altogether. And this was one of the more advanced plots I did. Um, so the data that we get, so I got it from Rampali and all that team. And their team conversely processed the data from the K2 satellite, Gaia satellite for positioning, and is given in distance and parsecs, declination, and right ascension to place on the sky. So I converted that to Cartesian coordinates with this formula. And I also shifted the plane. This is a formula that I worked out to shift it by simply taking the midpoint of where the stars are on the x-axis, the y-axis, the z-axis, and then shifting every point by that amount so that I can shift the axis so that it's centered in Praesepe. And then what I finally did was I used this equation that I got from the I Lecture Online guy, and to get the center of mass along each axis, which I'll put the center of mass on the x, y, z axis. I was able to put together as a 3-vector, and I shifted the axis so it's at the center of mass of Praesepe. So as you can see, this is 0 right there. So that has centered the mass, the axis there. And you can see at the bottom, the coloration of these stars are indicated in the color of the marker. The lighter blues rotating faster, the darker blues are rotating slower. And the same thing, the marker size represents the mass of the star. Now, interestingly enough, when I tried to do my final analysis, I had difficulty. I don't remember what the error was, but I was having some issue working out with the center of mass coordinates. So I actually went back to just the regular center coordinates inside Praesepe, and it wasn't that far distant. It was like one axis was about 15 parsecs away from the center of mass, and the other two was only between 2 and 5 parsecs away. So it wasn't that much different, but it was enough for an initial estimate. So I actually went back to that coordinate system. And what I decided to do was to split Praesepe into several slices along the XY plane. I tried to convert the coordinates back into spherical again, which I had difficulty doing. I didn't realize until later that I was dividing by 0 with the origin. But suffice to say, I just decided to slice Praesepe into slices along the x-axis, z-axis, and y-axis, and get the amount of mass and rotation in each of those slices. Another thing I noticed was that, like, when I added up all the stars and all the masses, I got about a 511 solar masses. When I excluded the stars that didn't have all the data I needed, I had 1,012 stars. So when I had the entire cluster printed at once, I had all of that. When I cut it into two slices, half and half, I still got 511 solar masses and 1,012 stars. But I noticed that the more slices I added, the count became more and more accurate. Like there was an overlap or some data was missing somehow. So I limited it to 8 slices along the x-axis and y-axis and 16 slices along the z-axis. That seemed like enough to get an initial estimate without introducing too much error into the analysis. And so what I came up with is this. So if you look at this, this is looking at the YZ plane of Praesepe. So the x-axis is coming out the page. And I did slices along the X. I found out the location of the highest concentration of mass, lowest period of rotation. Same thing on the Y, same thing on the Z. As you can see on the X-axis between -11 and -5 parsecs from the center of mass, I had this period, which is the lowest concentration of period of rotation, 8.7 days. 8.8 days on the y-axis between 1 and 7 parsecs, and 7.3 days between 20 and 30 parsecs. For the mass, between -24 and 17 of 0.9 solar masses per star, it was actually 1 star on that axis, so don't have an error margin there. On the y-axis, -17 to -11 parsecs was 0.62, and the z-axis, 0.54 solar mass. So that's not the most massive star there necessarily, but the average of all the stars in that slice, the average of these stars in that slice, that gives you the higher average mass and the lowest average solar rotation. That's what those slices are. When I overlaid those slices on the graph, this is what we see. So we can see that these three stars here represent the highest concentration of mass. So they're not the largest stars. You can see from the size of this star here that is larger than those stars. But if you look at this slice, there's several smaller stars in that slice that would have made that average less in both directions. Here, there's a lot of smaller stars near those stars, and here vertically, there's a lot of smaller stars. So the average would have made that one bigger. And on the rotation side, you can see that if you look at those stars, those do have a lighter shade of blue in them. So it makes sense that this slice here would have the fastest slice of rotation. As you can see, a lot of darker blue there everywhere else. So this section does, according to this resolution of slices, has the highest concentration of fast rotators. So what I found was contrary to my expectations. The mass and the rotation is not on average distributed radially. It's quite, if not random, definitely asymmetric. So interesting. Interesting is to have a better understanding of these clusters of stars and how things are distributed. Spent a lot of time making various plots, 3D plots, rotating the plots just to see what the structure of the stars looks like. And it's actually more shaped like an oval. It might be kind of hard to see. You can see it a little bit. Like if you look at this image here, it seems sort of more flat. So you can see we're looking towards from the side a little bit. So it's just the stars are distributed rather like an oval a little bit, like not a perfect oval, of course, but it's sort of oval-like. But the mass of distribution and rotation is distributed rather uh, asymmetrically, probably the best word to say. So in conclusion, future work, what I'm going to do, I'm going to work out some automatic Artesian conversion because maybe because I did it manually, it just wasn't able to work properly. So I'm gonna have to increase my coding ability so that I can actually code this automatically. Um, I may see about, and actually my mentor told me I don't need to actually convert it back to spherical. I could just use it as it is. So I may skip that part. I just focus on increasing my coding ability so I can automatically convert it to Cartesian coordinates to make sure that that was accurate, and automatically do it in slices. And in the future, after I work out in detail, so for March, I'm just going to do one, and my mentor advised, because it's going to be a lot of work getting the accuracy and precision down to the level I need for March. So I'm going to spend all my time perfecting that over the winter break and over the spring. But once I do get that worked out, I'll be able to easily apply this to other clusters and also see how the distribution is across different clusters. That's that. Y'all can let me know if you have any questions about anything. Do y'all feel any questions, any comments, anything came up? I think this is a beautiful picture, by the way. The Praesepe picture here. What's my son picture is a beautiful picture as well. Awesome. Well, hopefully you enjoyed. And what I'll do is switch over to uh, the debate. So the more will come on that. It'll be a while for me to get the more detailed analysis. And what I'll do even thinner slices. We're not going to eliminate the error that's probably input for me manually slicing it. So I'll increase my coding ability so the coding is slicing for me, as well as so the coding could convert the coordinates for me. Maybe there's an issue with that. I'll be able to confirm that that's accurate, and I'll have a higher resolution understanding of distribution, and we can see if perhaps at a lower slice, higher resolution slices, maybe I might see something different. So we'll see. So let me switch to debate.
Yeah, you said earlier that.
Just the sound.
I said that it proves that the sun is a local light because we're supposed to have parallel rays, but we don't observe that in reality.
That's not what we heard you say earlier. We said that perspective rays prove where the sun's at.
I said it proves the sun is local.
So I like that more people now are holding these flat earthers to their claims and what they say. As first says, I moderate a YouTube channel watching Northern Lights from Churchill, Canada. Nothing going on right now from there. Okay.
Local.
Yeah, so where's the sun?
Local. The sun is local. That's where it is. Not in 93 million miles away in outer space.
How do you prove that?
I just showed a bunch of stuff. The sun changing angular section. That for and I use. You said the
I thought it was good. He was holding on to what they say. That's not the clearer part. I went a little bit ahead of what I wanted to talk about. This comes right here.
You're running away from your claim here, John. You said the horizon always rises to eye level. Now you're making excuses. You're making excuses for. You're making excuses. Hold on, let me talk. Let me talk, John.
MC has.
So the idea is that the flat earthers were saying that the horizon always rises to eye level, which we heard them say that nonsense before. So Now, the Robert is a pilot who's going to show some images that he took from his plane, debunking that. And I want you to hear how the flat earther responds. And then we'll go back to how MCToon utilized that, which I thought was so funny. So let's check this out.
You could look at it.
Looking's not a measurement.
Yeah.
Why don't you use a tool like a theodolite to measure it?
Because the horizon is apparent. What's the definition of horizon?
Feel free to jump in, Kevin.
Go ahead.
Can you tell me the definition of horizon?
Yeah, you're running away from your claim here, John. You said the horizon always rises to eye level, and now you're making excuses. You're making excuses for. You're making excuses. Hold on, let me talk. Let me talk, John.
MCToon is going to Antarctica. My understanding, him and a group of them. But let me know how the volume is, by the way. Is the volume okay between me and the video? Let me know if I need to turn myself up or down or turn the video up or down. Is okay? Awesome. But yeah, I believe they are going. Me myself, by the way, I don't really understand it. Like, to me, I think we should spend the money on like actual scientists to go. I don't see why we spending all this money to send them there when they're going to deny anyway, the flat earthers. I mean, I guess there's still entertainment, and of course, you know, MCToon is pretty prevalent. So I'm sure they make some good money from these streams and things like that. So I mean, there's reasons to do it, I guess, from that perspective. But just from the perspective of these people there, I don't know. I would just let them wallow in their ignorance. I would just spend the money on something else. But again, I don't have a channel that's making a whole lot of money at least at the moment. So you know, maybe that's why it's not so interesting to me. But I'm sure it'll be some interesting thing to see. Of course, we know they're going to see what we expect to see on the globe. So it'll be interesting to see how the flat earthers respond to it. But you know, we have people talking about let's send them to orbit or something like that. Of course, some of them joking about just sending them and leaving them there. But I'm just saying, I don't see the point in spending money and trying to prove these things to people. They're going to just lie and deny anyway. And even if the ones who go come back and say, oh, we saw the sun do it. It was supposed to do it on a globe. The Earth is a globe. Everybody else, all the other ones are going to say that they got to them, right? We've seen it happen before. When they get out of it, when some of them get out of it, or everybody else says they're shield, they've been bought, or they got to them, they, you know, whatever. Or they were never a flat earth. They were lying the whole time. You know, it's just nonsense anyway. But it is amusing. It is entertaining. Now, this guy has his own image of the horizon not rising to eye level. And of course, you know, if you're on any type of surface and you're going higher and higher and higher, of course, the surface will be going down and down and down. With a globe, it's curving away from you as you get farther away, which makes it even more drastic. And that's what we're seeing there. So right here is the crosshairs of the actual horizontal. And then we can see that the horizon, the curvature of the Earth is lower than that, which contradicts, it totally debunks the nonsense claim they made. So let's see what the response is.
I said you can't measure the horizon because it's an apparent position.
Okay,
why am I here?
Let's give Mike a chance to respond.
Yeah.
We don't want too much crosstalk. So Mike hasn't had as much floor time as Robert and John so far, so we're going to give him the floor. And Kevin, like I say, feel free to jump in. Well, not any time. I'm giving the floor to Mike, but you know, within reason. So go ahead there, Mike.
All right. John made the very specific claim that the horizon always rises to eye level, and we have on screen right now a measurement of the horizon not rising to eye level that Robert did himself. It's easy to measure the horizon and whether or not it rises to eye level. Everybody that has a smartphone has the ability to do that. You can install an app that'll measure that, and that's what Robert did there. So this is a falsification of your claim, and all of the words you've done, and all you've done is you've said, oh, never mind, all of the claim that you said now suddenly doesn't matter.
Okay, I just want to talk about your picture here, Mike. I know that these pictures were coming, but how hard is it to fake these pictures? You know, there's an horizon and just draw an X there and write some number in the corner.
Hang on. Let Kevin respond.
I'm going to share my screen.
All right, just 1 second, guys. Let's let Kevin wrap his point.
Well, that's what I was saying. I knew pictures like that were coming, and so they're circulating on the internet in Facebook groups, kind of pictures like that. They add a cartoon line over the horizon line, and they say, look, it's over the eye level. Even more ridiculous than that, they have water container and they put it over the horizon line. They take a picture and look, it's over the eye level. Okay, can I share my screen now?
No, hold on. I just want to say, Kevin rejected evidence
picture, this cartoon. This is a cartoon.
Hold on one second, Kevin. I don't want to start the mutes. Let's let Mike respond, and then we'll keep
Kevin rejected other people's firsthand taken evidence without any reason. So Kevin's standard, yes, Robert took that photo himself. Kevin's standard of evidence is to automatically reject things that everybody, including the people that were here, personally did. So Kevin, you do not get to apply a second standard of evidence to yourself. You must apply the same standard of evidence. So I'm going to say everything that you present is faked.
Yeah, and that's your standard of evidence. Very last point of this picture. This is a picture of a head.
So, and Toon is going to stick with that, as you said, Splurge. Toon is quite interesting. So, he caught him saying that, and he's going to apply it. So let's go to that part. So I thought this is like so hilarious. This is like the most funny thing. But let me find that part real fast. So now we have 8 minutes later, something like that. We have that guy Kevin wanted to present some videos he took.
Okay, that's all the time I'll take. Thank you.
Yeah. Your Google summary results don't beat this textbook by an actual surveyor.
But it's not because it's written in a.
This is the premium Garmin duffel 45 liter by Half Day. It's a transforming 2-in-1 travel duffel bag for long.
Book.
I want
our audience, once again, smash that like button, help boost us up in the algorithm. We got quite a crew hanging out here at Modern Day Debate, watching the show and participating in our poll. Right now, we are currently sitting at 34% flat, 53% are saying it's a globe, and the 13% say it's a loaf of bread. All right, so once again, get your super chats in, grill the speaker that you really just don't find that they're getting to it or whatever. I don't know. Let's just carry on what Kevin's showing here. Looks very nice.
It is nice. And when you're there, that experience of being there, it's like you can't see it like on a screen like that. You see the view from forward. But when you're there, this is the sky pod at the CN Tower. There's 2 levels that you can go. This is the highest level, the sky pod. And you can't explain the feeling of having a 360 view like that, eye like that, and you can see that the horizon is at eye level. No matter how high you get, I don't need a cartoon line on a fake picture that Robert didn't take, even if it's
not a measurement. That's just an observation.
I can show you a lot of picture in my phone that I didn't take. Okay, I can assure you of that. It's not a proof that you took the picture because it's in your phone. I'm sorry about that.
Kevin, next time you do that, load the tool on your phone and measure the angle to the horizon, so you come back with an actual measurement.
Yeah, sure.
Not a baseless
claim.
Okay.
Sorry. I'll do it. Okay.
Okay.
But I got another video.
Can I respond?
Just one second. We do want to make some space for some back and forth. So I gave you the floor for that space there. You can leave your screen share up. That's totally fine. But we're going to let Mike respond to what you just put out there. And then I want to bounce John in here too if he's got some thoughts. So go ahead there, Mike.
Okay. Well, that applying Kevin's standard of evidence is obviously faked. That's just a video that's been handed around on the internet.
Let's turn off the audio if you don't mind. If you're going to share.
It's obviously that Kevin just generated some CGI of that. It's not actually his. He didn't actually take it. Kevin can't accept that evidence. It's not acceptable evidence by Kevin's standards. So definitely just disregard that evidence because Kevin obviously didn't take it himself.
All right, I'm going to take you off.
I thought that was wonderful. So MCToon came, and you notice I did that same thing with what's that guy's name? I don't remember who the moon landing guy's name was. But I was partnering with FTFE, and FTFE was presenting his evidence, and the guy was just denying it baselessly, and throwing out these nonsensical things that has to be met. So then when he presented his evidence, I pointed out that he wasn't applying the same thing to himself. So this is just a common refrain that they have, where they have these double standards of evidence. So I'm glad that MCToon is calling them out on that. I think it's so hilarious. And watch how he comes back, by the way.
Mute there. Let's carry on. So you want to explain what you got up there on screen, and go ahead when you're ready there, Kevin.
Yeah, okay, because he thinks it's not real, I'm going to play it with the sound, and we can hear my voice.
So I'm on the top of the CN tower.
That's right, Spirit.
That's fake.
Ice flat horizon.
Yeah, it's totally fake.
Now it's flat.
And we see Robert jumping in too. It's like, that's fake. So they both are, boy. MCToon again is like, yep, that's fake. They're applying the same logic, right? But watch how Kevin tries to justify it.
Okay, so I'm going to put it on mute, and I'm going to say, Robert, there's a reason why I told you, okay, I'm looking forward to see your footage from inside your cockpit. Footage, not photo on your phone. Yourself coming in the cockpit, okay? Like you can hear myself talk like on the film. If you say it's not real, it's fake, you didn't take it, you are a spectacular moron, and you deny reality. I'm sorry, Ryan, for the insult, but that's what it is. You can hear myself talking, okay? And what's interesting in that movie, okay, is that my P900, I just bought it. This is a footage I took in 2019. And my P900 was brand new, so I brought it. This is a footage taken with my phone, by the way. And at some point, I put out the P900 to try it, okay? And at some point, the P900, the science of technology, okay, it's very brief, okay? It detects a yellow line. I don't know if you can see. I took a screenshot, and I have it in my phone somewhere. But look at the horizon at some point. You see the yellow line there? It detects a perfectly straight line, okay? And this is for kilometers. This is very far, okay? So the red, everybody saw the yellow line?
All right, you've had lots of floor time. Let's try to bounce it a little bit.
Okay, well, I'll come back with that later. If you cut me off, I'll come back with that later.
All right, well, that obviously is faked. A video can't be, it's inadmissible. Applying Kevin's standard, you can't actually you take video or photos that you took yourself. It's not allowed per Kevin.
You're not the only one that can have a cheap.
So interesting thing is, Kevin was saying that his delusional excuse is, oh, you could hear my voice on the video, but you could apply the same logic he applied to Robert. How easy is it? Or how hard would it be to fake video with your voice in it, right? It's free video software you can get where you could take a video and put whatever audio you want on the video. But the flatter, illogical, delusional mind doesn't, it is blank. Yeah, exactly. But so the same logic works, but for some reason, Kevin, it just, what is it? What is this, Verge? I mean, obviously he's smart enough to think that something could be faked. So what is it that makes him somehow just totally dissociate that when it comes to audio on the video? Why suddenly now, if you hear your voice on the video, oh my gosh, that's just, is just perfectly proved. And of course we know if Robert did take a video of him, that same thing with the horizon and had his voice on it, they would still say it's fake, right? So I just thought this was an amusing exchange, and it's very telling, the mindset of the fighter, because remember, he said that they were morons for believing his video was fake, and they're denying reality because he could hear his voice on it, but he denied their picture. So according to him, he's the moron. It's just, I thought this was so. I saw this so many times. I laughed so much at these two sections. So I thought that was awesome. So one more thing I want to show. I thought this was a good call out by Mark Reid. This debate is apparently going on right now. But you know, I sort of despise this flat earth on the lower left right here. I've seen the Percy cats absolutely demolish him. But I've just seen him lie so much. Like I remember one time he was debating, who was it? Plainer Walk, I believe. Oh no, that's Nathan Thompson right there. So that's Nathan Thompson on the lower left. But even though, yeah, I mean, I've I've found him to be a liar as well, a witless as you call him. But of course, they're all liars. I mean, we know they're all liars, right? It doesn't take it doesn't take you don't have to listen to them talk for long to for them to come out with some kind of lie or deception or something. But I remember he was debating, I believe it was Plainer Walk, and there's this video where Neil deGrasse Tyson is debunking flat Earth, and he points out how the Eratosthenes well experiment. He said if you use 2 wells, you could do calculations to make that work on the globe or a flat Earth. But if you increase it to 3 wells, it can only work on the globe, and it does work with 3 wells, so the Earth has to be a globe. What Nathan did was he spoke only about the part of the video where Neil deGrasse Tyson said it works on both if you have 2. And Plainer Walk kept asking, well, what did Neil deGrasse Tyson say in the same video if you use 3? What did he say in the same video if you use 3? And Nathan just kept avoiding the question. But I don't know if he knows, like if he may, because, you know, these people, they just investigate on a surface level. Maybe he listened to just that part of the video and said, aha, and just stopped it right there. It's possible. These people are very ignorant and they don't really want to learn. So it's possible he only saw that part of the video and didn't look at it anymore. And it's possible he saw the whole video and just lying and just denying it. But whatever the case is, he didn't want to address Plainer Walk asking him. Either he could have said, oh, well, I didn't watch the rest of the video. What does he say when he talks about 3 wells? Or he could acknowledge that, okay, yeah, he does say with 3 wells, it works only on the globe. But he denied both of those and just kept avoiding it. So that's just one of the examples of how dishonest I've seen this guy is. So I didn't even, but you know, out of curiosity, I was opening it up just to see what was going on. And this is how Mark Reid started. I've seen that video. He filmed himself at that school or whatever, trying to, what he's called it, flat smack the elementary school kids. But you know, if it wasn't for this guy that I know personally that really believes it, I mean, you know, these people, some of them really believe it. I know some people say that people like Nathan Thompson are witless, uh, 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 they can't be that stupid. But some of these people really are. They really believe it. So, and I don't remember. I was watching an ex-flat earther interview, and the guy was saying he knew these people, and they believe most of them really believe it. So crazy. But let's play with how Mark Reid addresses him.
I can take it. That's totally fine. Thank you so much, Nathan, for the introduction there. Sorry to speed things up a little bit there. But yeah, that was 6 minutes. So, 6.5. So yeah, if you guys take that a little extra time, that's totally fine. We got super chats already flying in. Our audience is already highly engaged. Mark Reid is now sharing his screen. Oh my, I gotta stay right on that screen share tonight, fellas. You know how it is for a flat versus globe debate. I'll be fighting for that screen share button. All right, so Mark Reid is gonna do his up to 6 minute intro. So thanks for coming back, Mark Reid. The floor is yours.
Sure. Just before I start, I just want to point out that Nathan required us to send our arguments ahead of time, and we'd only stick to those arguments. He's already violated that. So the liar, in fact, is Nathan Thompson, who wants us to sort of do something, we do it, and then, as like total hypocrites do, completely change the rules of the engagement. So I'd like that to be noted, that he isn't actually sticking to the rules of the debate that he demanded, of course, because, well, he's a child and he's a liar. So I thought sort of...
So I thought that was awesome. And I noticed that this is a common thing with flat earthers. I remember one of the first ones I talked to back when I first learned that people actually believe this stuff. And the friend I was telling you about, who I knew personally, so I know people really believe it. He was trying to convert me, I guess, or whatever. and he helped me talk with what's his name, Riley. They call him Liley, and I found him to be quite deceptive and manipulative. But I remember speaking with him, and he did the same thing. He at the start of our talk, he said, "Well, let's do this, and let's have it that way, and let's have it that way." And through the debate, he contradicted every single one of the things he outlined. So it's like, I don't know if these people are just posturing, trying to, I'm going to set the rules. I'm going to, or they want to make it seem like they're going to be so thorough, or maybe they really just, I don't know, just manipulative, trying to get you to focus on one thing so that no, it's Riley. Let me find out who it is real fast. It won't take a moment to find out, and that's what the last thing I want to show. So I'll take the stream off. Yeah. In fact, it's on my channel. Let me find a video because the link is sure. Let me just find a video and I could just share that. Actually, thinking about it, I can show you what I'm talking about. So it'd be easier to find. Hopefully, I didn't quickly delete it or something. Let's see. Maybe I should go to my playlist. Even to find it there. Sleeping Warrior. That's why I had his. Maybe I need to actually put his name Riley in there so it's easier to find. Sleeping Warrior. I forget his name is Riley something. Oh, Riley in the title. So that's why I couldn't find it because I was trying to search for Riley. So this is the video here. So you can see me talk to him. This is from when 6 years ago. And so I think it's an interesting watch. Now, at this period of time, I wasn't trying to debate him or anything. It just my what happened is my friend, I was debunking all the nonsense he was saying. And so he diverted to, well, it's just you have to talk to somebody who's a real fact, because he was giving me videos and I was debunking that, and I was debunking what he was saying. So then he started to divert to, well, you need to talk to a real flat earther. These videos you seeing, all the stuff you're finding wrong, they're not real flat earthers. And if you just talk to a real flat earther, then you'll know. So that's why I ended up talking with this guy. So, and at the beginning, you'll see he's like, oh, well, we're going to do this and let's do that. And he's all, but as you can see, as we go along, he's contradicting every single thing he set out as a basis for the talk, just like how Nathan had did. So, I don't know, perhaps it's not even conscious. I noticed that so many of these people have the same deceptive, manipulative patterns. Um, I'm starting to conclude that it's just when you have these people who are just delusional, it just manifests in the same ways. It just these same fallacies come out, the same type of deceptions and manipulations. It's amazing. So I was going to do psychology. If I did it, I would have been. This is probably would have been my some of my research in psychology. So that's probably my main research interest in it is a psychological perspective. Um, Yeah, man, it's crazy. But yeah, so y'all should check it out. Let me put the link uh in the chat here, the live chat. And actually I have a few. Make sure this came out properly. Yep, yeah, that seems to be the one. Actually, I have a few debates and talks that I did over the years. So y'all should check it out. Just go to my channel. I talked with this guy. He was big at the time. I talked with DITRH. I had a talk with journalism on a panel on my channel. So yeah, look through some of my old videos. You see some interesting things. I had like a 6-hour debate with this guy named Fight the Deception. I hosted a debate with Sean Hawkins versus SC Montreal. So y'all know Sean Hawkins. He's cool. So yeah, so y'all can check those out. But yeah, it was interesting talk, and it's interesting that he did that today. Nathan is doing the same thing he did 6 years ago by setting up all of these prerequisites for the talk and then breaking every single one. So it's interesting, man. But awesome. That's all I had today. A little bit about Praesepe, a little bit some of the amusing things I've seen on the debates recently. And let me know if anybody have any topics or anything y'all like to discuss. Next week will be finals week. Then I'll be off for the winter from school at least. So y'all can let me know what topics y'all want to cover during the winter. I'll probably find some science topic or something like that. And if you have anybody you'd like to talk to, I remember there was this guy, I remember his name now, but he came talking about there's no real pictures of Earth. And I invited him to come on. Of course, he made a 180 and all of a sudden his mic doesn't work well and so on and so forth. You know how it is. But if you're listening or you come watch this, whoever you are again, just let me know and you can come on. But you know how it is. They want to just protect the delusion away from any potential to hear facts. So you like to just come in and spout the nonsense and then run. But if he's there and he wants to talk, if I'm wrong about that, then come on and we could talk about that and we could hear the ignorance of believing that there's no real pictures of Earth. Awesome, y'all. I'll see y'all next week.